Yeah, welcome to my channel, Data Scientist in the House. We'll be looking at K-means clustering today. In the class of K clustering, we have the K mode, the K median, and the K means. The K means happens to be the most popular. Now we'll be looking at K means clustering. Now, when we look at, say, the most frequent use partitioning method, and among the most popular clustering method in general is K-means, as I mentioned earlier. And the algorithm can be summarized as follows: input x1 to xn as these x1, x2 up to xn, they belong to set of real number in the dimension, number of K clusters. Then we do the initialization, set of clusters of mean 1 to mean K. Then the iteration, we repeat the process, the steps until there's convergence. And by saying convergence simply means when there is no changes in the center of the clusters, because you'll be given some set of data, x1, x2, as the case may be, or x or y, depending on the dimension. Yeah, then we can use Euclidean distance, Manhattan distance, and any other distance that is applicable. Now let's look at what it looks like. The schematic illustration of K-means is provided here. We have plot A to J. Now the A there simply means the green means the data provided, and the B is the center of the clusters. Then the C, as we have above, represent the subsequent session after we assign the x1, x2 to the center of the cluster. Then the D up to J represent the assignment after the calculation is being done, the successive steps through to the final convergence of the algorithm that we can see. So we are going to be having an illustration shortly. Now, the closest cluster is typically determined by the x1, x2 distance, such as the Euclidean distance, Manhattan distance. So those are those are the things that are used to determine the distance, to measure the distance between two clusters. Now let's look at let Z subscript IK be the indicator point of Xi being in the cluster. Then we have equation 1, which optimize, or we can say minimize, the total distortion. Okay, let's look at numerical example. Suppose we wish to perform K-means clustering with the following data set containing 5 observations and 2 variables, x1, x2. We have x1, 0, 0, 6, 8, and 8. Then x2, 0, 2, 1, 0, 2. Suppose that our random initialization ends up with 2 clusters, centers. That is, we have 2 closer centers, no more than 2. So, and the closer center for 1 is x1 is equal to 5, x2 is equal to 1, closer center 2, x1 is equal to 8, x2 is equal to 0. Now, let's look at how this can be solved mathematically. These are an example of a question that you can find in machine learning, unsupervised machine learning. Now, let's look at this solution. We can have point A is 0 and 0, that is xy. Point B is 0 and 2. point C, 6 and 1, point D, 8 and 0, point E, 8 and 2. Now let's look at the assignment. Assign to cluster 1. That is, point A is assigned to cluster 1. Why? Now look at what cluster 1 looks like. We can see that in the center of cluster 1 for X1, we can see that we have 0 there. The center is 5. Is 5 over there. Now look at point B for X. Is 0 also is closer to 5 than 8 for X. Point C, 6 is closer to 5 than 8. So we assign these to cluster 1, point A, B, C to cluster 1 each. Now let's look at the assignment. Now we assign point D and E to cluster 2. Why? Now in cluster 2, the X there is closer to 8, which is X1 equals to 8 and X equals to 0. Also, the X there, which is 8 also for point E, is closer to 8. So that's why we do the assignment. So what we now need to do next is we had all the x's, which is 0 plus 6 divided by 3. Okay, this is the initial iteration. I did iteration 0 is just by assignment. So we have it is represented in this plot. Now, what we do now is we had x 0, 0, 6. We had them all divided by 3. That is the mean. Then, and 1, 0, and 2. We had them up, which gives us another, which is what? 1. So we have the center, the new center is what? 2 and 1. Now, we also average 8 and 8 for this cluster 2, which gives us what? 8. Then 0 and 2 again for the point here, which gives us 1. When we have range 0 and 2, we have 1. So now we have a new cluster. New cluster center for 1 and 2 to be 2, 1, 8, and 1. So now we can see that we have a new center and represented in this with this graphical illustration. Now we go again and conduct the, since we have a new center, we can look at center, look at the initial data given. Then we do it again. The new cluster center for cluster 1 will then be the average observation of 1 and 2. Now we can see that 1 and 2, we have, when we average 1 and 2, we have what? We have 0. You can see 0 plus 0 over 2 give us 0. And the new cluster center for 2 will be the average of observation 3, 4, and 5, because those are the ones closer. By the time we do that, we are going to have 7.33. Now, then 1. 6 plus 8 divided by 3 gives us 7.33. Then when we had 1 plus 0 plus 2, we are going to, divided by 3, we are going to have 1. So we have new centers to be, center 1 is 0 and 1, center 2 is 7.33 and 1. Okay, so we're now going to continue the iteration. We can see the figure. We can see the plot for that right here. Now, the next thing we are going to do is to do the iteration again. By the time we start the third iteration, we will see that Observations 1 and 2 goes for center 1, 3, 4, 5 goes for what? Cluster center 2. So there are no changes. Since there are no changes, therefore there's convergence. And that implies that we have our cluster A, B goes to cluster 1, and C, D, E goes to cluster 2. And that's easy end of that. Now, the next thing we are going to do is to go to the Python lab and compute this in Python. We are going to compute this in Python. Yes. Now we are at the Python Jupyter Lab, where I'll be demonstrating how we can obtain this k-means clustering using the Python. Now, the three packages needed there is what? NumPy, we need pandas, then matplotlib.pyplot. Then the next thing, the first thing we do is just to bring in our data, 0, 0, xy, 0, 2, 6, 1, 8, 0, 8, 2. Then the initial clusters are defined to be 5 and 1, the center, the two centers, 8 and 0. Okay. Now, the next thing that we're supposed to do while writing this code is to define our assignment. We assign data on the left, then centers on the right for easy identification. Then we use the function np.admin_distance as is equals to 1 plus 1. Then we proceed after the assignment because we are actually carrying out k-means clustering. So we are required to define each assignment, and the iteration needs to be well defined. And that is why all the initialization has been done up here. So, and our data has been defined, the center has been defined. Then we proceed and have our plot. Then with the iteration, that's the title. Then the label x1 for x-axis, then x2 for y-axis, then the grid. Now the iteration loop, we also define the iteration loop as we have here. Also the plots, talking about the plot for the current state is there. Then the update centers, we have it there. Then we have our iterations, so that we have assignment underscore clusters, x, comma centers. The iteration has been defined. Then the final state, all the necessary iteration has been included in the code. Then we can see the output. The output is given as DOS, initial iteration, just like was explained earlier. The assignment defined here. You can see the plot produced. The iteration 1, you can see the plots as displayed earlier. Iteration 2, that's when the convergence was achieved. And we can see how the whole thing works. So this particular Python explanation provides to us how it can be done when we are outside the classroom environment or examination condition. But the earlier one that was provided with manual computation is an example of where you are being examined or you have exercise to solve such a problem. But this particular one is being demonstrated. If you have large numbers, this may not be done this way, particularly the manual computation. If the data set is large, it cannot be done manually. So we resort to the software computation. And it's always good to have the background to know how to do all this manually so that we appreciate when we see it using software such as this. So with this, I believe you have been equipped, particularly with the manual computation. A lot of students find it difficult to compute or to solve problems relating to k-means clustering, but this has been presented to us and how it is done. Thank you.